Ever wondered why questions are so powerful? Let's take a moment to ponder this. Questions are the sparks that ignite the fires of curiosity. They are the keys that unlock the doors of knowledge. They are the seeds from which the tree of learning grows. Without questions, our understanding of the world would be as barren as a desert. Consider some of the intriguing questions that often pique our interest. Can you really grow a salt crystal at home? This question might lead you on a journey into the realm of chemistry, teaching you about the fascinating process of crystallization. Or how about, does lemon juice conduct electricity? This question could propel you into the world of physics, unraveling the mysteries of electrical conductivity. And then there's, do plants grow faster with music? This intriguing query might send you exploring the intersection of biology and sound waves. So, are you ready to explore these fascinating questions? First up, can you really grow a salt crystal at home? Well, let's dive into this intriguing topic. Salt crystallization is a fascinating natural phenomenon that occurs when a solution of salt and water begins to evaporate. As the water disappears, the salt doesn't have enough room to stay dissolved, causing it to form into a solid structure, a crystal. The science behind this process is all about the way salt molecules, or sodium chloride if you want to get technical, interact with each other. When they're in a liquid state, these molecules are free to move around, but as the water evaporates, they start to slow down and stick together, forming a crystal structure. Now let's get our hands dirty and conduct a simple experiment to grow our very own salt crystal. The beauty of this experiment is that it's safe, fun, and you can do it using common household materials. Here's what you'll need: a glass, water, a tablespoon of salt, a piece of string, a pencil, and a paper clip. Start by dissolving the salt in warm water. Next, attach the paper clip to one end of the string and tie the other end to the pencil. Place the pencil across the top of the glass so that the string dangles into the water but doesn't touch the sides or bottom of the glass. And that's it. Now all you have to do is wait. As the water evaporates over the next few days, you'll begin to see salt crystals forming on the string. So, it turns out you can indeed grow a salt crystal at home. Fascinating, isn't it? Growing your own salt crystal is not only a fun project, but it's also a great way to explore the magic of science that's happening right under our noses every day. And who knows, maybe this little experiment will spark a lifelong love of science and discovery in you. After all, the world is full of wonders, and it's up to us to uncover them. Now, on to our next question: does lemon juice conduct electricity? Let's start with some basics. Electricity, at its core, is all about the movement of electrons. In order for something to conduct electricity, it needs to have something called free electrons. These are the little guys that can move around easily and carry an electrical charge from point A to point B. Now, when it comes to lemon juice, we're dealing with something known as an electrolyte. Electrolytes are substances that contain free ions, which are atoms or molecules with an electric charge. When these ions are free to move, they can carry an electrical charge, making the substance therein conductive. So how do we find out if lemon juice is one of these conductive substances? Well, we conduct an experiment, of course. Imagine a lemon, a couple of wires, and a small light bulb. We insert the wires into the lemon, one at each end. One wire is connected to the positive side of the light bulb, and the other to the negative. If the lemon juice can conduct electricity, the free ions in the juice should carry the electrical charge from one wire to the other, lighting up the bulb. The moment of truth arrives. We connect the wires and voila, the bulb lights up. The free ions in the lemon juice are indeed carrying the electrical charge from one wire to the other, proving that lemon juice can conduct electricity. So there you have it. Lemon juice with its free ions can indeed conduct electricity. It's not going to power your house or charge your phone, but it's enough to light up a small bulb. And that's pretty impressive. These everyday wonders are all around us, hiding in plain sight. All it takes is a bit of curiosity to uncover them. Lo and behold, lemon juice does conduct electricity. Who would have thought? Finally, do plants really grow faster with music? This question may sound like the premise of a science fiction movie, but it's actually a topic that has sparked a good deal of intrigue and research. Let's start with the theories. One popular hypothesis is based on the idea that vibrations caused by sound waves can stimulate plant growth. This theory, known as sonic bloom, proposes that the vibrations can cause tiny movements in the plant cells, which can speed up the process of nutrient uptake. Another theory suggests that music might mimic certain natural sounds that plants are responsive to. like the buzzing of insects or the rustling of leaves, which could trigger growth responses. These theories are fascinating, aren't they? Now let's get down to our little experiment. We've set up two identical plants in identical conditions, with one key difference. One plant is serenaded with sweet melodies for a few hours each day while the other sits in silence. Over the course of a few weeks, we observe the plant exposed to music seems to be flourishing, its leaves reaching out as if trying to catch every note. The silent plant, on the other hand, while still growing, doesn't quite match the vitality of its musical counterpart. Could it be that the music is indeed having an effect? Perhaps. But it's also important to remember that many factors can influence plant growth, and our experiment is far from a controlled scientific study. That said, the idea of plants responding to music isn't as far-fetched as it might initially seem. After all, plants are living organisms just like us. They react to their environment, they adapt, they grow. And if music can make us humans feel good, who's to say it can't have a positive effect on our leafy friends too? So, it seems music does have an effect on plant growth. Isn't that something? We've explored some fascinating questions today. We've journeyed into the realm of the everyday, turning the mundane into the extraordinary. We saw how a simple kitchen ingredient like salt could transform into a dazzling crystal, right in the comfort of our homes. Then, we delved into the electrifying world of citrus fruits, discovering that a humble lemon could indeed conduct electricity, and who could forget our melodious adventure with plants? We learned that music, the universal language of emotion, could potentially influence their growth. These explorations, these moments of wonder, are the essence of curiosity. It's this insatiable thirst for knowledge that propels us forward, that drives innovation and discovery. So let's keep this spark alive. Let's continue to question, to explore, to learn. Remember, never stop asking questions. You never know what you might discover. Until next time, stay curious. Let's dive into another intriguing question. Do we really only have 5 senses? Most of us were taught about the traditional 5: sight, hearing, taste, smell, and touch. But is that the whole picture? Sight allows us to perceive the world in vibrant colors and intricate detail. It's our window to the world, our primary source of information. Then there's hearing, our connection to the symphony of sounds that fill our lives, from the soothing lullaby of the rain to the exhilarating roar of a thunderstorm. Taste and smell work hand in hand to enhance our gastronomic experiences, while touch lets us feel the texture of life, from the softness of a petal to the roughness of a rock. But what about our sense of balance that keeps us upright, or our ability to feel temperature changes, or the sensation of pain? Aren't these senses too? And let's not forget our internal senses, like the awareness of our body's position and movement, or the sense of hunger and thirst. Our understanding of senses has evolved over time. It's not just about the traditional 5 anymore. Researchers believe that we may have up to 20 or more different senses. So, it seems we indeed have more than just 5 senses. Isn't that something to consider? This just goes to show how much there is still to learn and discover. So keep questioning, keep exploring. In the next scene, we'll wrap up our journey of curiosity with some final thoughts. Stay tuned!